Good day to you viewers. You are welcome to my page. Comrade Alani is my name. Today we're having physics. Let's solve this question on the board together. As you can see, whenever you have a question like this, the easiest method that we can use is to apply something I called the 4G system. The 4G approach system is very simple. The first thing to do is for you to ask yourself, what's the topic under which the question was done from? Then two, you ask yourself, under which subtopic? Then you ask yourself again, what is that parameter that I'm told to found? Then on the last note, you ask yourself, what is the formula that will take me to the promised land? Now, without wasting time, so let's go back to the question. 3 5 ohm resistors connected in parallel. So this topic is done from a topic called current electricity. Current electricity, the subtopic is under the arrangement of resistors. Arrangement of resistors. So then the formula that what we are actually told to find, that is the current I, which is depicted, it can be depicted by capital letter I. Then the formula that connects what we are told to find together is that is the formula from the Ohm's law. V is equal to IR. V is equal to IR. But before we proceed, I can just give a little explanation of the diagram on the board. 3 5 ohm resistors connected in parallel. This is how parallel arrangement looks like. So you can see 5 ohm, 5 ohm, 5 ohm, 3 5 ohm resistors. 1 2 3 3 connected in parallel. So this is parallel arrangement. We have two arrangements. We have series arrangement, we have the parallel arrangement. This one is under parallel arrangement. Potential difference of 60 volt. This is the 60 volts applied. The acceptable standard is that whenever you are having resistors arranged in parallel like this, or you are having parallel arrangement like this, the two of them, all of them are going to have the same potential difference, which you can see on the board. The current in each resistor, that is what we want to find. Now back to our formula. Our V now is 60 volts. Our I, that is what we are looking for. Our with our the resistance. So that is so please, some students will tend to waste their time by trying to reciprocate all these values. In this case, you don't need to reciprocate anything. Look at the question. The current in each resistor. Current in each resistor. See the current moving like this. When you get to this junction, it breaks. Some portion moves into 5 ohm, the first 5 ohm, another portion moves in second 5 ohm, the another portion move into the last 5 ohm. But because the resistors are of the same value, it means the same amount of current flows into each of them. The same amount of current flows into each of them. As a result, we are looking for the current in each of the resistor, not the total current in the circuit. So now you can just use your resistor now is 5 ohm, that is for only one. Now we have making your V, using our V is equal to high half, where V is equal to high half, making I to be our subject of the formula. You have that is a V over half, which will be 60 divided by 5, and your answer will be 12 amperes. So ladies and gentlemen, brothers and sisters, the current that will flow in each of these resistors is equal to 12 amperes. So who can tell me the total current that will then be here? So that means the total current that will be in the circuit, that will be the answer when you multiply this by 3. When you multiply this by 3, you get 36. But you are not told to find that. This is only what you are told to find. Remember, it means 12 ohm, 12 amperes will flow through this first 5 ohm. 12 ampere will flow through this first 12 ampere, the same 12 ampere will flow through this. If that occurs, that means what's the amount that will now that will have been flowing here? It means the addition of this, and this, which is 12 in 3 places, making 36. But the question says current in each resistor. Current in each resistor, which is your answer. Thank you very much. Bye for now.